This is a 9-disc Tower of Hanoi problem. The object is to get these discs from this peg to this peg. Now the only rule is you can't put a disc on top of something that is smaller, a disc that is smaller. So a question in mathematics is how many, or what's the minimum number of moves it takes to move it over. With 9 of them, it's going to be pretty hard to figure out right off the bat. So we break down the problem and do these one step at a time. So what we're going to do is we're going to take them all off, and we'll start with 1. When there's 1 disc, it takes 1 move. And you can do it to any peg you want from 1. Alright, so now with 2 discs, we're going to try to move it here. So what we're going to do is first move this one to the middle peg, move that one there, and then move there. Now notice that took 3 moves to do that. I take 1 move to move the top one here, just like it did 1 move before. Takes 1 move there, and then 1 move back. So the first disc took 2 of the same moves, of 1 move, how many it took, and then 1 to move the new disc. So now if we do 3 discs, what I'm going to do is I'm going to move the top 2 here. So the moves will go just like we did before. I'm going to move this one here, the bottom one, second one there, and that took 3 moves to get it to there. Now we take 1 move to move 1 disc here, and now I'm going to move the 2 back there, and again that takes 1, 2, 3. Now I have 3 discs there. So now if we do 4 discs, what I want to do is move the top 3 here. Now this should take me 7 moves, because the last one was 3, 1, and 3, which is 7. So this one should take me 3 moves to get these to here. Okay, there's my 7 moves. Move it once. Now I have to go 7 here. So I'm going to go 1, 2, 3, 4, 5, 6, 7. So that took me 7, 1, and 7. Alright, now if I continue that pattern, I should be able to do all these discs. So let's stop and figure out mathematically how many ways that we can do this.
So we're going to let n be the number of discs and an be the number of moves. We've seen that with 1 disc it only takes 1 move, so n's 1, an's 1. Our 2 discs, we have 3 moves. We saw we moved the top one once, the bottom one once, and then one more. Then with 3 moves we got 3, 1, and 3, and with 4 we got 7, 1, and 4. But we can see that what we have is we're taking the previous one twice and adding 1 to it. So it gives us a formula for n that it's the previous one doubled plus 1. So an is equal to 2 an minus 1 plus 1. So now, this is called the recursive form. To turn this into an explicit form, again we know that for a1 we got 1. So if I plug that into my a2, I'm going to get 2 plus 1. And I'm not going to simplify it, even though that's 3, because you'll see as we go along that what that means is I'm going to get a form that I'm going to build on. So I get 2 plus 1. For a3, I take the previous one, 2 plus 1, I double it, and add 1 to it. So I distribute the 2 through, get 2 squared plus 2 plus 1. A4, again I take the previous one, double it, add 1, so when I distribute the 2 I get 2 cubed plus 2 squared plus 2 plus 1. And we can see that what we're getting is a geometric series with a ratio of 2, because you can write 2 to 2 to the 1 and 1 as 2 to the 0. So in general, we're getting an being 2 an minus 1 plus 1, and then we sub in the previous one. As you can see that we start at an exponent that's 1 smaller than our index, which is n. So I go 2 to the n minus 1 all the way down to 1. Now, if I want to simplify that, I have to use the fact that we have the sum of the geometric series. And if you add up 1 plus the ratio up to n, you get this formula that's well known. Maybe we'll do that in another video, of a quick one of how to calculate that. But you apply that to what we have, and since we're going to n minus 1 plus 1, that's just 2 to the n, and it simplifies to 2 to the n minus 1. I would get the minimum number of moves necessary depending on the number of disks, which is 2 to the n minus 1. So now we can calculate when n is 9.